This is part 3 video on venturi tube experiment. So this is the data that we had to collect, delta P at different locations 1, 2, 3 and 4 as per the manual. So here is the diagram of the venturi tube. We have reference selected at the inlet of the tube left side, and then as we move, location 1 is at the center where we had the smallest area in smallest diameter. So pi d square by 4, you get the lowest area there, and then diameter increases, so the area is increasing. So at those 4 locations we measured the relative static pressure. It is the pressure which is measured perpendicular to the flow direction. So the fluid is moving from left side through the tube and exits the right side, and perpendicular to that flow direction we have put the pressure tapping points and the tubes connected at these 4 locations. So it is a perpendicular measurement which is done for static pressure measurement. So those 4 data you are going to plug in here. Once you have done with analog device which is called manometer there, and the second time you have repeated the experiment with a digital device, the name is CASI, provided by the supplier. So the same exercise, you do it 2 times and plug in this table. There is no as such there is no calculation to do here given in the manual. So we will do plotting of that data, and on the x-axis you have area in centimeter square, A1, A2, A3, A4, again provided in the manual the area values. On the y-axis you will put delta P values which are measured. So take the modulus. If you are getting a negative sign there with the digital device, you take modulus, so you have a good comparison. Both the manometer and digital device, you take absolute values, and the units, bring it in the same unit for both the devices, keep it in Pascal. So you get one curve for the analog device, another curve for the digital device. Area values again are mentioned here, A1, A2, A3, A4, again taken from the manual. You will find this inside the manual in centimeter square at location 1, 2 and 3 and 4. So these 4 values you are going to map to these pressures: A1 at location 1, A2 at location 2 and A3 at 3 and A4 at 4. So correspondingly you have delta P's, so that you have to map, and whatever type of graph you get, you can get a linear curve, or sometimes you can get a different kind of curve, parabolic or exponential. So you see what data you get, based on that you plot the curve. So that is all about data measurement and then representation in the form of graph.